Hello students, in this video I am going to discuss about the dielectrics topic, and these are the topics I am going to discuss in the coming videos. The basic definitions in the dielectrics: electronic polarization, ionic polarization, piezoelectric materials, pyro and the ferroelectric materials. So let's see the definitions one by one. So what are dielectric materials? Among the insulators, some materials, when they are placed inside the electric field, dipoles are forming. The positive charge and negative charge are getting separated in the presence of electric field. Such materials are called dielectric materials. So dielectric materials are insulators, and among these insulators, dielectric materials will form dipoles in the presence of electric field. In these dielectric materials, only the charges are getting separated apart, but they are not the free charges, and they have the permanent electric dipole moment. So there are two types of dielectric materials. One, the polar materials, and the two, non-polar materials. Polar means we know that where already the positive and negative charges exist in the molecules itself. For example, we can take HCl. Hydrogen will have the partial positive charge and chlorine will have the partial negative charge. So this already is having some polarity, the positive and negative. In the absence of electric field, we can see here they are randomly in their own direction. But when they are placed inside the electric field, they will align in a particular direction, like negative charge is getting attracted towards the positive charge and positive charge getting attracted towards the negative charge. And non-polar dielectrics, particles or the molecules or the atoms where there is no separation of the positive and negative charge in the absence of electric field. The positive and negative charge exist together in the absence of electric field, but when they are placed inside the electric field, the positive and negative will get separated, and we can see here the positive charge aligned towards the negative terminal and negative charge is aligned towards the positive terminal. The examples for these non-polar dielectric materials like methane, benzene, etc. The next definition comes to the electric force. This electric force is the Coulomb inverse square law. The force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. And the proportionality constant, we can write it as 1 by 4 pi epsilon naught. So F is equal to, this force is the electric force. Either it can be attractive or repulsive. If the two charges are like charges, it is repulsive forces, and if the two charges are unlike charges, it is attractive force. So the force of attraction or repulsion between the two charges Q1 and Q2 is given by F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and the units of the force is Newton. It is a vector quantity. Here we know that Q1 and Q2 are the two charges and R is the distance between the two charges, whereas epsilon naught is the permittivity of free space. The value of this permittivity of free space is 8.85 into 10 power minus 12 farad per meter. For a medium, actually here this epsilon naught is the permittivity of free space. If a medium is placed between the two charges, then F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where epsilon is the permittivity of the medium. Units of this permittivity is the farad per meter. What is this permittivity? The permittivity means, see, suppose a medium is there. So the medium, some media will allow more electric field lines to pass through them, and some media will allow less electric lines of force to pass through them. So the property to allow the electric field lines to pass through this medium or the substance is called the permittivity. The more the permittivity value, if epsilon is more value, means it is allowing more electric field lines to pass through. If the epsilon is small value, means it allows only small number of field lines to pass through them. Electric field. Electric field means if we place a charge here, to what area its influence can be felt. This is called the electric field. Mathematical expression can be given by electric field strength, that is E. As here Q charge is placed at the center, so in this area how much electric field is there, means that it is given by Fe is equal to the force per unit charge. E is equal to F by Q. And we already know that F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So E is equal to 1 by 4 pi epsilon naught Q by R square. And the units for this electric field is Newton per Coulomb. It is a vector quantity. And its direction, we know that electric field direction is from positive charge to negative charge. Next definition, electric flux. Flux means the field lines. So the field lines passing in that electric field in that area. So the flux is represented with symbol phi, and phi is equal to E into A, where E is the electric field intensity and A is the area. Units of this flux is voltmeter, and it is also a vector quantity because electric flux means it is the field lines. So if we place a charge here, the field lines will be moving from the positive charge to the negative charge. And next definition, electric flux density, which is also having another name, electric displacement vector. It is represented with letter D. So this electric displacement vector is defined as the electric field lines passing normally through an unit area of cross section. So D can be defined as the charge per area. The surface area of the sphere is 4 pi r square. So D can be written as Q by 4 pi r square. The units for this is, the unit of the charge is Coulomb and unit of the area is meter square. So Coulomb per meter square. Now let's see the relation between the electric flux density D and electric field strength E. We know that E is equal to 1 by 4 pi epsilon naught Q by R square. So if I rearrange this 1 by epsilon naught into Q by 4 pi R square, which this one is equal to D. So D by epsilon naught. So we got E is equal to D by epsilon naught. From this, we'll get D is equal to epsilon naught E. This is in the case of free space. Whereas for the medium, D is equal to epsilon E because epsilon is the permittivity of medium. The next definition is dielectric constant, which is also having another name, relative permittivity. So relative permittivity definition is the ratio of the permittivity of medium to the permittivity of free space. So epsilon r is equal to epsilon by epsilon naught. This epsilon r, which is also can be represented with k. So k is equal to epsilon by epsilon naught. So it doesn't have any units. Then dipole. Dipole means which is having two poles. So two equal and opposite charges, that is minus q and plus q. Their magnitude are same. It is having q only. But one is negative charge minus q and another is positive charge plus q, separated by a distance. Here the distance I have taken it as 2a. You can take it as d also. It's up to your wish. Just whatever the notation we are representing, we can take in terms of 2 or else we can take just simply a letter. So these two poles, the positive and the negative pole, are separated with a distance. There it is called dipole. The next definition is dipole moment. So as we discussed in the starting, the positive and negative charges are getting separated. How much distance they are getting separated? So basing on this, dipole moment is given. So the dipole moment is the product of the charge and the distance between them. So here the distance I have taken it as q into d. So mu is equal to q into d. As in the previous figure, we have taken it as 2a. So we can write this mu is equal to q into 2a also. So whatever the distance we are taking, basing on that, this formula will be changing. So as if we are taking 2a, it is q into 2a. If we are taking d, it is q into d. Units for this dipole moment is Coulomb meter. It is also a vector quantity. Its direction is from negative charge to the positive charge. Next definition is polarizability. So the ability to form dipoles. So if you are taking a material, in this material, the positive and negative are getting separated. The ability to form these dipoles is given by this polarizability. So this dipole moment is directly proportional to the applied electric field. More the electric field applied, more the dipole moment. Less the electric field applied, less the dipole moment. So mu is proportion to E and the proportionality constant is polarizability. Hence polarizability is defined as the dipole moment per unit electric field. And the units for this polarizability is farad meter square. It is also a vector quantity. Then next definition, polarization. So this polarization means process of forming the dipoles. How many dipoles are forming throughout this material? So throughout this material, losing the neutrality of the atom or the molecule. And mathematically it is given by the polarization vector. How many dipoles are forming? So per unit volume, P is equal to, the polarization vector is represented with letter P. P is equal to N mu, and we already know that mu is equal to alpha E. So P is equal to N alpha E. And the units for this polarization vector is coulomb per meter square. Can you guess what the other parameter having the same units? Here we can see this electric flux density is also having the same units, coulomb per meter square. Even the polarization vector is also having the same units. Now let's see a small relation between this electric flux density and the polarization vector. Okay, now let us consider a small specimen and it is placed under an electric field and hence the dipoles are formed. This is the polarization. How many atoms are forming? This is the polarization vector. So inside the material, whatever the electric field is created, it is equal to P, and externally the applied electric field is E, and hence so the electric flux density is D, right? This electric flux density is given as D is equal to epsilon naught E plus P. So for a medium, D is equal to epsilon E. So therefore epsilon E is equal to epsilon naught E plus P. From this, P is equal to epsilon E minus epsilon naught E. And we can write this epsilon as, by using the relative permittivity definition, epsilon R is equal to epsilon by epsilon naught. Hence, epsilon is equal to epsilon R epsilon naught. Therefore, epsilon R epsilon naught E minus epsilon naught E, that is equal to, we can separate epsilon naught epsilon R minus 1 into E. So this gives the relation between polarization vector and the dielectric constant. So the next definition is electric susceptibility. See, till now we have seen that when an electric field is applied, dipoles are formed. How much extent these dipoles are formed and how much they can sustain in this material, or how long they can sustain, that it is given by the susceptibility value. More the susceptibility value, these dipoles can stay for longer time and it is having more applications. The polarization that is happening inside the material is proportion to epsilon naught E, and the proportionality constant is susceptibility chi E. So P is equal to chi E epsilon naught E. From this we can give the formula for susceptibility. Chi E is equal to P by epsilon naught E. Hence it is the ratio of the same dimensions. So the susceptibility doesn't have any units. So this susceptibility indicates the degree of polarization, to what extent it can get polarized and how much time it can sustain that. So the greater, more the susceptibility value, the greater the ability of the material to polarize in response to the field. So as we have seen, chi A is equal to P by epsilon naught E. See, you can get a doubt here, why this E? This E represents the electric susceptibility. Even magnetic susceptibility is also there. There we'll use the symbol chi B. So P by epsilon naught E. Already we know that P is equal to epsilon naught into epsilon R minus 1 into E by epsilon naught E. So this E and this epsilon gets cancelled. Finally, susceptibility chi E is equal to epsilon R minus 1. So once you know the dielectric constant, then you can know the susceptibility value. So more the dielectric constant, more the susceptibility value, and it has the greater ability to get polarized in the presence of electric field. This is about the basic definitions that are having in the syllabus of the applied physics for first BTech students under JNTUH Hyderabad.